Dear colleagues, my name is Ruснак Максим Вячеславович. I'm a third-year student of the Pavlova State Medical University. Let me present the work on the preservation of glycosaminoglycans in the fabrication of hydrogel from the human umbilical cord decellularized matrix. Violation of the integrity of the structures of human tissues and organs is a very common phenomenon, despite the level of development of modern society. Sensitive deep wounds can lead to the complications and death. Preparation of the inflammatory process caused by injuries leads to the replacement of functional tissues with scar tissue, disruption of the physiological activity of the body. A promising method of regenerative medicine that avoids the consequences of injuries is the use of tissue-engineered acellular structures made of biological tissues. They can be represented as 3D matrix or hydrogel. The procedure of removing cells from the material is called decellularization, and the resulting product is matrix. Its transformation into a hydrogel is called solubilization. Optimal biomaterial of homologous origin, or the most suitable for the fabrication of tissue-engineered products, is a human umbilical cord. Let's see what advantages this material has. First of all, fetal phenotype tissues, such as Hydrogel of umbilical cord, contain a large number of growth factors that provide chemotaxis, proliferation, cell differentiation, and angiogenesis. The biomaterial contains the dominant number of anti-inflammatory cytokines. The cell's components of structure of umbilical cord favors healing. Part jelly of umbilical cord is characterized by the high quantity of glycosaminoglycans, among other biomaterials used to create hydrogels. Human umbilical cord products have a short regulation time that is important for use in vivo. In this experiment, we studied the preservation of glycosaminoglycans as a product from the umbilical cord extracellular matrix. The first stage is the preparation of umbilical cord and removal of two arteries and veins. Next, we isolated the congel is homogenized and decellularized. That means all cells are removed in order to avoid the formation of the recipient's immune response during the flotation of the tissue-engineered products. The crushed biomaterial is treated with a sterile natrium hydroxide solution for 4 hours and room temperature and shaken at 180 rounds per minute. Washing the product with deionized water removes slow debris and nucleic acids. For the next stage of solubilization of the product in the hydrogel, it's neutralized with the hydrochloric acid to pH 7.5 and lyophilized. Lyophilized and crushed decellularized matrix is solubilized with a solution of hydrochloric acid with a pepsin for 72 hours at room temperature and shaken at 180 rounds per minute. Pepsin provides partial integration of protein molecules with extracellular matrix, mainly collagen. The product is neutralized and added to the resulting hydrogel phosphate salt buffer with a volume equal to 1/9 with the volume of hydrogel solution. For long-term preservation of the hydrogel, it's lyophilized. Glycosaminoglycans perform many functions in the extracellular matrix. The figure shows a model of protoglycan aggregate with one of the forms of glycosaminoglycan existence in the complexes proteins. In polyanions, glycosaminoglycans attach water and cations, maintain tissue hydration and osmotic equilibrium. As an important structural component forming the matrix structure, glycosaminoglycans contribute to the diffusion of the traits and metabolites in the extracellular space. Mainly of glycosaminoglycans are chemoattractants providing chloroplast migration. It's known that glycosaminoglycans stabilize extracellular enzymes such as cathepsins, which provide hydrogel degradation, as well as signaling molecules modulating their activity. In our experiment, we investigated the preservation of glycosaminoglycans of the extracellular matrix after the fabrication of hydrogel. To do this, we finished The finished product was pulled into fertling and sections were made according to standard method of preparing histological preparations. Some of the preparations were pre-treated with a 1,280 international units of highland-based solution in a weight chamber for 12 hours to assess the rate of degradation of the main and most evident component of glycosaminoglycans, chlorinic acid. Further, the preparations were stained with alsan blue, pH 2.5. As is known, alsan blue interacts with both carboxylic and sulfur radicals of acidic glycosaminoglycans in pH. The difference in the color of the obtained preparations is visible with the naked eye. We can see staining in the case without enzyme treatment, but the preparation treated with haloridase are not stained with dye. Here are the results of light microscopic preparations. On the left, preparations without enzyme treatment, but on the right, preparation treated with haloridase. Thus, we revealed the presence of glycosaminoglycans in the manufactured hydrogel from the umbilical cord. The applied technology of hydrogel production using natron hydroxide solution and solubilization with a pepsin demonstrates the possibility of creating a product with preserved regenerative properties of native tissue. Treatment of histological preparations of the tissue engineered product with a specific enzyme, haloridase, and staining with alsan blue alone to confirm the initial presence of an important regenerative component. The study of properties of hydrogel continues, and here there are directions in which work is already underway. The picture shows a laboratory animal with a model of a layer skin wound, in which a hydrogel was implanted to study the biological activity of the product in vivo. Thank you for the attention.